Hello, this video is for IXL A1.C.1. It's titled Identify Equivalent Ratios, and the 3-character code for this activity is 8 uniform echo. So the question asks, are these ratios 2 to 4 and 5 to 10, are these equivalent? So first we might want to revisit what is a ratio, exactly what are ratios, what do we use them for, how do we represent them, and how can we compare them to see if they are indeed equivalent. Well, first let's remember that ratios can be written one of 3 different ways. We could, like they're written here, have 2 to 4, 2 to 4. We could also actually use the word 2. We could write down 2, T-O, 4. Or we could make it as a fraction, 2 to 4. Any of the 3 forms can be used to represent a ratio. So with that in mind, I'll just leave that up there because we're going to use one of those instead of 2 semicolon 4, 4 colon 4. Always confuse those two. We're going to write them as fractions. In this case, let's look at the one on the left. So I guess we'll do an example of boys to girls. It seems like a pretty popular example to use. Over on the left I have, it looks like, 9 boys? And I guess let's do this. Let's write boys to girls. So, because order does make a difference. If we're going to list the boys first over on the left, we're going to need to list the boys first over on the right. Otherwise, we end up messing things up. So, over on the left, we have 9 boys. And over on the left, we have, looks like, I believe, 4, 8, 12. I have 12 girls. So, over on the left, we have a ratio of boys to girls is 9 to 12. Over on the right, let's do boys to girls again. Here we have 3 boys, and for every 3 boys, there are 4 girls. So on the left, it's 9 boys to 12 girls, and on the right, it's 3 boys to 4 girls. Now, are these 2 ratios equivalent to one another? Well, it's easier to compare things if they were fractions, right? We've compared fractions before to see if fractions are equivalent. So let's go ahead and rewrite these ratios as fractions. So instead of 9 colon 12, we're going to write 9 over 12. We still read this as 9 to 12. And over on the right, 3 to 4, we're going to write as 3 to 4. Now the next question is, are they equal? There's a few ways we could find out if these 2 ratios are equal to one another. Remember, every fraction is a division problem, so we could divide them. 9 divided by 12, well, you could take a calculator and do that if you'd like, but it's going to produce a result of 0.75. And 3/4, hopefully we're all pretty good at converting fractions to decimals by now. We recognize that this also equals 0.75. So we could have done it that way. We could have just taken the fractions, because they are division problems, divide numerator by denominator, come up with a decimal number, and compare them. We could also use cross products as well. We could have, and I'm looking for a spot, I'm going to go ahead and erase this here to give me some room. And then let's also get these a little bit closer to one another. Move this over here, and we'll grab this 3/4 here, and we'll move that a little bit closer over here. So we can go ahead and consider, are these indeed equal to one another? Well, we could use cross products. We can multiply the extremes. The extreme is the upper left numerator and the lower right denominator. 9 times 4 is 36. And then we can multiply our means. Lower left denominator, upper right numerator, those are the means. Multiply the means, and we get 36 as well. So since cross products comes out equal as well, we could say that yes, the ratio of 9 boys to 12 girls is equivalent to the ratio of 3 boys to 4 girls. So with that in mind, let's go ahead and look at our actual problem that IXL is asking us here. Are the ratios 2 to 4 and 5 to 10 equivalent? Well, let's write them as fractions. 2 to 4. Is this equivalent to 5 to 10? Well, 2 over 4 we know works out to a fraction of to be 0.5, 1/2, and or decimal I should say. And 5 over 10, if we divide that out, that would also be 1/2. So we can see that yes, this does check out. We could have also used cross products, and that's probably the most common thing that I would do or that other people would do, is we could say 2 times 10, it's 20. 4 times 5, it's 20 as well. Turns out to be that they are equivalent. So the answer is yes. For the remainder of this activity, I will probably most often use cross products, but sometimes, who knows, I might go ahead and use the idea of multiplying the numerator by the denominator and compare decimal values. So on the next one, are the ratios 2 to 12 and 3 to 2 equivalent? So let's go ahead and write that. 2 is to 12 as 3 is to 2. Notice how I did that. 20 is to 12 as 3 is to 2. So I kind of just think that out. 20 is to 12. And whenever I write the equal sign, in my mind I'm thinking the word as. So actually 12 over 20 could be simplified to, we could divide them both by 4, right? 20 divided by 4 is 5. And 12 divided by 4 is 3. And over 3 halves. Now, if you simplify fractions, that's another way to compare them. If you simplify them all the way down, you should come up with the same fraction. I'm going to guess that these are not equivalent because I simplified them and the fractions are not equivalent to one another. So 5 times 2 is 10. 3 times 3, that's 9. This is a false statement. So indeed, these are not equivalent to one another. 9 is to 3 as 6 is to 2. Well, 9 over 3 will simplify to 6 over, what? No, 3 over 1, right? 3 over 1, divide them both by 3. And 6 over 2, well, divide them both by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. See what I mean? We simplify the fractions, and we end up with 2 equivalent fractions, so I know that they're already equivalent. Now I'll go ahead and use cross products, just so you can see for sure. 9 times 2, 18. 3 times 6, 18. Checks out. They're equivalent to one another. Select all the ratios equivalent to 6/5. Now this is one of those times to where simplifying the ratios down to their simplest form can actually help you compare them pretty well. 6 over 5. So let's consider 6 over 5. 6 is to 5. Now 18 is to 15. 30 is to 25. And 24 is to 20. So let's go ahead and see, can we simplify these? 18 and 5 both share a common factor of 3, don't they? 18 divided by 3, 6. 15 divided by 3, 5. 6/5. They match. 30 and 25. Common factor of 5. 30 divided by 5, 6. 25 divided by 5, 5. 6/5, 6/5. We have a match. 24 and 20 both share a common factor of 4. 24 divided by 4, 6. And 20 divided by 5, 5. 6/5 compared to 6/5. They are equivalent. Turns out to be that all 3 of these ratios are equivalent to 6 to 5. Now you could go ahead and cross product those if you wanted to, double check it, but I think you're going to find that it turns out to be okay. Select all the ratios equivalent to 4 over 4/3, or 4 is to 3. So let's go ahead and check this out. 8 is to 6, 28 is to 21, and 6 is to 1. Well, 6 is to 1, that's an improper fraction, and so is 4/3. So make sure that all of these are indeed improper fractions. Okay, if we had a ratio that sets up to be an improper fraction, we're comparing it to another ratio that sets up to be an improper fraction, or vice versa. If they're not both proper, or they're both not improper, then we know that they're not going to be equivalent to one another. So 8 and 6, common factor of 2, right? 8 divided by 2 is 4. 6 divided by 2 is 3. 4/3, 4/3. 28 and 21, both divisible by 7. 28 divided by 7, 4. 21 divided by 7, 3. 4/3, 4/3. Good to go again. And 6 over 1, well, 6 over 1 equals 6, right? So is 4/3 equal to 6? Indeed, it is not. So this one would not be true. Now, if we wanted to, we could set that up. 4 is to 3, as 6 is to 1. We could use cross products. 4 times 1 is 4. 3 times 6 equals 18. Does 4 equal 18? No, it doesn't. So therefore, this answer over here is not going to work for us. Select all ratios equivalent to 7, 6. Now they're giving it to us in fraction form, right? They're representing the ratios as fractions. So we have 7 over 6. And let's see. 7 over 6 is an improper fraction. See if we got any proper fractions over here. Nope, they're all improper. So first check's done. What about 15 over 14? Let's go ahead and do cross products for a while. Wow. 7 times 14 is 70, 98, I believe. 70, 28, 98. Yep. And 6 times 15 is 60, is going to be 90. Is 98 equal to 90? No, it's not. So the first one we can rule out. 7 over 6, let's try to set that equal to 18 over 4. 7 times 4 is 20. Yep, 28. Had to double check there. Is this equal to 6 times 18? 60 and 48. I know it's not going to be. It's going to take me way up there too far. 60 and 48 is 108. Is 28 equal to 108? Nope, it's not. So this one doesn't work either. Must be the final answer, correct? Let's try this. 35 over 30. They're both divisible by 5. 35 divided by 5, 7. 30 divided by 5, 6. 7 over 6, 7 over 6. Turns out to be, that's the only correct answer. Select all ratios equivalent to 8 over 14. This is a, here we go. 8 over 14 is a proper fraction. Proper fraction. You broke your arm the correct way. No, proper fraction. 8 over 14 is a proper fraction. The numerator has a lesser value than the denominator. So look over here, 7 over 4. That's an improper fraction, so we can rule that one out already. Now the other two, they're proper fractions. We're going to have to go ahead and check those out. So let's do the first one. 8 is to 14, as 32 is to 56. Now, to tell you the truth, I don't like the idea of multiplying by big numbers here. If I could simplify that, I would. So let's do 8 is to 14. Is this equal to, let's see, I think 4 would work for both of these. Indeed it is. They're both divisible by 4. 32 divided by 4 is 8. Imagine that. 56 divided by 4, 40 plus 4, 14. Imagine that. Checks out to be 18. 8 over 4 equals 8 over 14 equals 8 over 14. So we actually did it by simplifying it. But I simplified it not necessarily to find out are they equivalent. I simplified it mainly because I would rather do 8 times 14 than 8 times 56. It's going to be easier to do in my head. And then 1/2. Well, 8 over 14, is this equal to 1/2? Well, 8 times 2 is 16. So we know that 8 over 16 would be 1/2. And 8 over 16 is not the same as 8 over 14. So we could rule out 1/2. 15 over 3. Improper fraction, right? Numerator is greater than the denominator. Let's see, do we have any proper fractions? Improper, 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 improper. Okay, good to go. And notice we could simplify 15 over 3. Remember, every fraction is a division problem, so this is actually 15 divided by 3, and that would equal 5, right? So if we simplified 15 over 3, then we know that we would end up with 5. So we should see, are these equal to 5? 40 divided by 8. Yep, that equals 5, so this one works out. 26 divided by 1 equals 26, so 26 is not equal to 5. 39 divided by 7. Well, 7 goes into, let me see, 5 times. 7 goes into 39 5 times with the remainder of 4. Bring that in. So is 5 equal to 5 and 4/7? No, it's not. If you're wondering what I did there, is I just turned an improper fraction into a mixed number. How many times will the denominator go into the numerator? That's the whole number. What would be the remainder? That's the numerator. The denominator remains the same. I could do the same with this one here. 21 goes into 105 Well, 20 goes into 100 5 times. Get this. And 1 goes into 5 times. So it's going to be, if we actually did that, and you could check that out, 105 divided by 21. And I say it's going to go in 5 times. 5 times 1 is 5. 5 times 2 is 10. And lo and behold, it's going to go in 5 times. So this would simplify to 5. So this one's correct. So the first and the last are the correct answers. Select all ratios equivalent to 15 over 6. Well, I noticed that 15 and 6 are both divisible by 3. So I could rewrite 15 over 6 as 15 divided by 3 is 5. And 6 divided by 3 is 2. So I could compare everything to 5 over 2. I just simplified the ratio. So 5 over 2. Let's see. Let's go ahead and use cross products. We haven't done that for a little while. I kind of get in the habit of simplifying things all the time. So 5 times 16 is going to be 50 plus 30 is 80. And 40 times 2 is 80. So first one checks out. So therefore, this is one of our correct choices. 18 over 4. And we're going to compare that to 5 over 2. And 4 times 5, I want to always get used to multiplying your extremes first. I almost got lazy. So 18 times 2 and is 36. Is this equal to 4 times 5 is 20? Nope, not equal, so this is incorrect. On the next one, let's compare 5 over 2 to 32 over 8. 32 over 8. So 5 times 8 is 40, and I know that 32 times 2 is not 40, it's actually 64. And these are not equal, so this is incorrect answer. And then finally, we're going to compare 5 over 2 to 35 over 9. So 5 times 9 is 45, and 2 times 35 is 70. False statement, so the last one doesn't work either. And final question on this one here, let's try simplifying again, because I see 18 and 21 there. So 18 and 21, they're both divisible. Wait, hold on. 3. Yep, that's it. I knew there was a number there because they're 3 apart. Silly me. 6 over 7, right? 18 divided by 3 is 6. 21 divided by 3 is 7. So we're comparing everything to 6 over 7. So let's first see, this is a proper fraction. Any improper fractions on the way? This one here is. And we can rule that out. Because 6 over 7 is proper, 7 over 6 is improper. So we could rule that out. All the rest of them are proper fractions. So let's try to simplify each of them. 12 and 14 both share a common factor of 2. 12 divided by 2 is 6. 14 divided by 2 is 7. So this would check out. Good to go. 24 and 28, they are both divisible by 4. 24 divided by 4, 6. 28 divided by 4, 7. So this one checks out. And 5 over 9. Well, 5 over 9 is simplified as far as you can. And 6 over 7 is simplified as far as it will go as well. So once they're simplified down to the simplest form, then you can go ahead and just compare them. Are they the exact same fraction? Are they actually look identical to each other? 6 sevenths is not equal to 5 ninths, so we can rule that out as well. And that concludes all of my examples for IXL A1.C.1 Identify Equivalent Ratios. Good luck with your activity.